A $1,200 receiver used to weigh as much as your toolbox. Solid aluminum, discrete transistors, endless headroom. By the 1990s, plastic shells and peak music power output numbers took over, while the heart of analog sound seemed to vanish. Industry legends called it progress. But why did heavy, silver-faced reliability give way to lightweight features? And did audio quality really drop in this great shift? The answer may not be what you expect. A Pioneer SX 1980 tips the scale at nearly 28 kilograms. Its brushed aluminum faceplate gleaming beneath rotary knobs that spin with the resistance of a well-oiled vault door. In the early 1980s, receivers like this set the benchmark for what high fidelity meant. Solid, serviceable, and unapologetically overbuilt. The first impression is always tactile, cold metal, weight that demands both hands, and a sense of permanence. Each switch clicks with authority, each volume adjustment feels deliberate. Behind that silver facade, the engineering tells its own story. Discrete transistors, each mounted individually, form the backbone of the output stage. Massive EI-core transformers, sometimes rated at 500 VA or more, anchor the chassis, feeding banks of oversized filter capacitors. A model like the SX 1980 could deliver 270 watts per channel into 8 ohms, with a damping factor above 100 and total harmonic distortion under 0.03%. Numbers like these were not just for spec sheets, they translated into real-world headroom, tight bass, and the ability to drive even the most demanding speakers without flinching. Collectors and technicians still marvel at the serviceability of these machines. Through whole circuit boards, hand-soldered joints, and point-to-point wiring invite careful restoration decades later. The internal layout is open and logical, designed for access rather than cost-cutting. Even the smallest details, weighted knobs, engraved lettering, and thick aluminum panels speak to an era when durability and pride of ownership mattered as much as the music itself. The psychological impact is hard to ignore. Heft and metal become shorthand for quality, a bias reinforced every time a 1980s receiver outlives its warranty by decades. This is the standard by which everything that followed is measured. When later designs traded mass and metal for convenience and features, it was not just nostalgia that fueled disappointment, it was the loss of something tangible you could feel every time you powered up the system. By the late 1980s, the arms race in audio had shifted from the workshop to the marketing department. Spec sheets grew crowded with new numbers, and the language of power became more ambiguous. Instead of boasting about heavy transformers or discrete circuitry, advertisements began trumpeting features like remote controls, multi-source inputs, and digital displays. The introduction of the remote control around 1988 changed expectations overnight. What once felt like luxury became the new baseline. By the early 1990s, even entry-level receivers arrived with wireless remotes, digital volume readouts, and a growing list of convenience functions. Manufacturers seized on these trends, but engineering priorities changed. Surface mount technology and globalized production lines allowed companies to shave 30 to 50% off chassis weight and parts costs. Integrated circuits replaced rows of discrete transistors, making it possible to squeeze more features into slimmer, lighter cases. The result was a new generation of receivers that looked advanced but felt insubstantial compared to their predecessors. Power ratings, once a badge of engineering integrity, became a marketing playground. Peak music power output, PMPO, entered the vocabulary, inflating wattage claims tenfold over true continuous RMS ratings. A model might advertise 1,000 watts PMPO, but deliver only 100 watts RMS under real-world conditions. By 1993, consumer advocates and trade magazines were sounding alarms. The Federal Trade Commission and international standards groups began pushing for clear RMS disclosures, and by the mid-1990s, most reputable brands had quietly retired PMPO from their spec sheets. Archival advertisements from this era show the contrast in priorities. Where a 1982 Pioneer spread might highlight a 500 VA transformer and hand-soldered boards, a 1994 catalog page boasted surround sound modes, video switching, and a remote with 40 buttons. As one former design engineer recalled, by the 1990s, the pressure was all about features per dollar. Designers were told to add digital signal processing chips before anyone asked about the power supply. This feature creep did not just change what receivers looked like, it redefined what buyers expected and what designers could justify under the hood. The next question is simple. Did any of these new conveniences come at the cost of actual performance, or was it all just a matter of perception? Is 1990s gear underrated or deservedly forgotten? On the test bench, numbers begin to separate nostalgia from engineering. An audio precision analyzer feeds a 1 kHz sine wave into a late 1980s silver face receiver. Under load, the power supply sags less than 5%. Peak voltage barely flinches even during sudden bursts. Filter capacitors rated at 22,000 microfarads soak up the stress, while the transformer 500-volt ampere core keeps the rails steady. Slew rate checks in at 35 volts per microsecond, fast enough to preserve the sharpest transients. Damping factor measures above 120 at 1 kHz into 8 ohms, translating to grip on the woofer cone that is visible on the oscilloscope trace. Decay is clean with no overshoot. Distortion spectra reveal a second harmonic dominance at 0.08%, a signature often linked to the warmth collectors describe. Next up, a 1990s black plastic receiver faces the same gauntlet. The transformer, half the size at 200 volt amperes, struggles to maintain voltage during a 1 kHz burst into 4 ohms. Sag spikes to 13%, visible as a dip on the scope. Reservoir capacitance drops to 7,800 microfarads, and the rails show more fluctuation under load. Slew rate comes in at 12 volts per microsecond, slower, with square wave edges that round off earlier. Damping factor falls to 45, and the speaker cone trace shows a slight lag, with more overshoot and less control in the bass. The STK power module posts a lower total harmonic distortion of 0.03%. But the spectrum is flatter, with odd-order harmonics creeping in. A former design engineer turned repair technician reviews the failure logs. Discrete transistor output stages from the 1980s average a 7% failure rate over 3 decades, mostly from dried capacitors or thermal fatigue. By contrast, STK modules in 1990s receivers show up in the shop with a 25% failure rate, often from thermal runaway or cracked integrated circuits. The technician points to a stack of black plastic chassis on the shelf. These modules run hot. Once they fail, you cannot just swap a transistor, you are looking for a rare part or scrapping the board. The oscilloscope captures the final difference. On a drum transient, the 1980s unit output voltage rebounds in under 40 milliseconds. The 1990s model sags, then recovers more slowly. The numbers suggest a trade-off, lower distortion on paper but less headroom and resilience when the music gets demanding. For those who value measurements, the gap is more than just a matter of taste. A relay-based ABX switcher sits between 2 receivers, one silver, one black plastic, wired to a pair of identical speakers. The room is quiet except for the faint click of the relays as a skeptical collector, eyes closed, reaches for the remote. Each track plays twice, the order randomized. The goal is to determine whether the audible difference is real or just imagined. Blind listening tests like this have become a rite of passage in audio circles, stripping away the comfort of cited bias. When the faceplate vanishes and all that is left is sound, results often surprise even the most seasoned ears. In a 2021 online survey, 60% of listeners picked the vintage receiver as their favorite when playing vinyl. The numbers flipped on CD playback, with 55% preferring the 1990s model. The margin is slim, barely more than a coin toss, but the pattern is consistent. Psychoacoustics offers a clue. Harmonic distortion, measured in the lab, does not always translate directly to what we perceive. Second-order harmonics, more common in 1980s discrete designs, blend with the music and are often described as warmth. Higher-order odd harmonics, sometimes more prominent in amplifiers based on integrated circuits, can sound harsher, but at low enough levels they slip beneath the threshold of detection. Studies suggest that most people cannot reliably hear distortion below 0.3%, and the shape of the spectrum matters more than the total amount. Expectation also plays a powerful role, revealing bias. Weighted knobs and cool metal prime the mind to expect quality, while a featherweight chassis can plant doubt before a single note is played. Even experienced listeners admit that the feel of the gear colors their impressions, no matter how objective they try to be. The numbers on the analyzer tell one story, and the human ear, shaped by memory and touch, sometimes tells another. The debate remains. Does the soul of a receiver live in its measurements or in the experience it creates? Today, nostalgia fuels demand for heavyweight receivers, while digital convenience now dominates new gear. As streaming compresses music and design chases lower cost, the debate over what we have lost, or simply redefined, remains unresolved. In audio, weight and value rarely align. The real question is this: what does authenticity sound like now? Share your take below.